All right, everyone. Good morning, good morning. So, thank you all for coming. We are here today to do a little bit of a post-mortem style of a little bit of a hellish horror story that I went through at my current role and have seen in consulting for a while. And it's basically how the apparent knocking of heads between people who are responsible for maintaining systems or keeping systems up, keeping systems efficient, and those of us who are responsible for securing systems, how when those things are at odds, things can actually end up worse as a result of general atrophy than better. And so, first things first, my name is Robert Wood. I currently run trust and security for a little healthcare analytics company called Nuna, based out of San Francisco. As of about 2 weeks ago, I moved back to the DC, Maryland area, so East Coast once again. And Nuna, just at a high level, when I say healthcare analytics, basically what that means is we are an ETL company solely based in AWS. We are what Gartner and other marketing companies would label as cloud native. So everything we do is some form or fashion of infrastructure or services that we don't actually own and operate. We configure and manage and utilize them and apply them, but we don't own them. It's either SaaS or stuff that we're rolling ourselves or deploying open source stuff on AWS or Google Cloud Platform, et cetera, et cetera. And prior to that, I was consulting for a good many years. So, setting the stage for this little this crap show that I was on, to use proper language, PG language. So, when I initially came into Nuna, I was security hire number 1 there. And at the beginning of my tenure at Nuna, there was a lot of hand-rolled systems. It was an early-stage company, but not even at just early-stage companies. Like many big enterprises, you end up with new projects that are getting started, and people are experimenting. People are building things. They're trying to do the right thing, and they end up just rapidly putting stuff together, experimenting, and those things kind of end up in production. And so we had a lot of stuff that was hand-rolled or snowflakes in some form or fashion. We had a lot of people who were, they knew how a particular system was configured. Their personal keys were the ones that were on those. They weren't necessarily backed up anywhere. Things like that. For those that have lived this nightmare scenario before, you would call our bus factor very, very high. That is, if one of those critical folks got hit by a bus or won the lottery, if you prefer the less dramatic scenario, we would have been screwed. And so initially I started off with the small team that I was building, very much focused on putting in initial security controls. So because we were a healthcare company, we of course were subject to your typical regulatory requirements like HIPAA, high tech, high trust, and that includes the security and privacy rules. And so, like any good company operating in that space, we invest, we build these security controls into these systems, and we launch it into production. And so at the end of the journey, what we'll kind of work our way to is moving away from hand-rolled systems into gaining a few IDs or a few abilities or properties of our systems. And that is consistency, observability, security, and then ultimately, I think one of the biggest takeaways here is how doing some of these things or focusing on some of these things, at least in my experience, ended up leading to cost savings and ended up making friends for the security team around the company. And friends help you get things done. Friends help you grease wheels. And so, starting off, we have to first clarify why this is a problem. So a lot of security frameworks or security mantras, security conferences, security papers, security blogs, et cetera. The general operating knowledge is that we start by building security into our systems, and we operate and we follow the secure SDL system where we start off, we design things really securely, and then we move in and we have requirements, and we have static analysis, and we have penetration testing, and we have ongoing operation and maintenance tasks, and we have this nice little feedback loop that includes incident response should crap inevitably hit the fan. And so we have all of this stuff focusing on building security into a system. But our security frameworks and our security operating knowledge does not actually focus on maintenance. And if we don't focus on maintenance, what we end up with is a situation we're in now where the world is releasing more and more code, more and more systems faster than ever. And if we're not focused on maintainability, then our systems inevitably atrophy. I don't know if we could do a quick show of hands, how many people in their places of work or in the past have ever come across some kind of legacy IT system that they had to patch, but they could not patch? All right, yeah, so we've all been there. So, and those legacy IT systems, the reason you can't patch them is because somebody tells you that they're serving some kind of mission critical function of the business, or nobody knows if you bring it down to bring it back up, if it'll even come back up. We have no idea if that'll work. You kind of pray to the patching gods every time that you go through a maintenance window, or anytime Patch Tuesday rolls around, and cross your fingers that nobody set auto update to on anything critical, where a security patch gets rolled out and then blam, everything is lights out, or a system just restarts as part of its patching process. And so over time, if we're not focused on maintenance, we end up with this increasingly widening gap of vulnerabilities, because we're ultimately finding more issues in our code, and if we can't patch them, if we can't maintain our systems, then we can't address the stuff that's already there, and we're releasing more stuff that in the future, we roll it out, it's all nice and shiny, but over time it gets dirty. It gets, we start to find things, researchers poke holes in it, et cetera, et cetera. And so it's this increasing pile of technical debt that we're accumulating. And that's exactly what we ended up in. And so day one, this was as the company was getting started, and this is not necessarily unique to my organization or to anybody's organization, because we've all been there at some form or fashion. And it's not necessarily just for your flagship products, but it could be for some oddball system that's just hanging out in the organization that somebody rolled out to serve a purpose one day, and then voila, it just existed, and it lived on. And so the first thing that oftentimes pops into the product managers, the executives' heads, is we have to give the customers the features that they want. We have to get it done now. We've got business development folks out. They're trying to make sales. They're trying to bring business in, bring dollars in. That's what funds the security team anyways, so we have to support that initiative. Great. The not so high priority things, the non-sexy capabilities of a system or properties of a system, are how do we constantly redeploy it? How do we maintain it once it's out? I.e. apply patches to it, i.e. at the system level or at the application level. How do we make security group changes or firewall changes if you're not operating in the cloud? How do we scale it? A lot of folks believe that if they're operating in the cloud, a lot of these things are just taken care of for you, because isn't that what the cloud does? It magically solves all of our problems. Is another kind of misnomer. And what inevitably ends up happening is a lot of time goes on. I don't know if this was actually 730 days later, but it was a long time later in my particular case. And we roll out, and what we were building gets out the door. It's shiny, it's secure at the moment, and it is a success. And so then we start having this condition where more people want that tool. So it was only ever built for a small set of customers to get it out the door. But then what if our customer count jumps by 50, jumps by 100, jumps by 200? Well, if you're a B2C style customer, you've probably planned for this, but in a B2B environment where you're working mostly with enterprises, sometimes you don't consider it. Sometimes your company may have agreed to special one-off features with a particular customer, and those are baked into one instance of the product, but not another. Those things can really come back to bite you in the ass. And at that 730-day mark, you then have to start asking yourself, as the security team, is the thing still secure? Oftentimes regulatory requirements don't change rapidly enough to keep up with these things, but you probably have seen some amount of CVEs come out on the underlying technology that you're using, whether it's the development frameworks you're using, whether it's Nginx, Apache, whatever the case is, you've probably seen some vulnerabilities come out. We see it, like our stack is pretty basic. We're running Django on Nginx servers. We've got Splunk forwarders. We've got a few particular agents. We've got SSSD to log into to use AD managed SSH logins, and Ubuntu just had a crazy issue the other day with SSSD, and for half a day we could not log into any of our servers, which is a lot of fun. And then of course, after a while, you have to start asking yourselves, can we still redeploy these things? Because sometimes in the early days, you might not have to. It's up, it's making a customer happy, they're smiling. And then, of course, the inevitable scale issue. So we ran into this pretty frequently where we just thought we could throw on an auto-scaling group or drop an instance in an auto-scaling group in AWS, and it would automatically scale out to billions of instances and it would work. But we found that we weren't actually engineering for longer-term distributed scale. We were doing processing on very inefficient processing of data. And most of our business is ETL focused, which, as you can imagine, is probably, we're going to run into a lot of really expensive computations very, very quickly. And, the bigger threat to us would just be running ourselves out of business because of our AWS costs. And so after this instance, this 730-day point where, we start rolling things out, and we start asking ourselves these reflective questions, is around the time when I got hired. And so coming from the consulting world, I came in very much like this. I'm a huge Batman fan. I have a sleeve, a suit, everything, which there are no pictures here, but if you want to see them, ask me. So I came in very much like this, crashing through the windows, and was like, we have a lot of issues. We've got to start fixing stuff. We need to, I found secrets hard-coded into source. I found, old databases that haven't been patched. I found all of this stuff, and there was a lot of drastic recommendations made as a part of that. And I've seen a lot of security folks fall victim to this trap, and it was just that. It was a trap for me. So. That did not actually work out. And so I ran into 3 sets of problems. And I want to cover the challenges that kind of the minefields that I walked into with each of these problems and how we solved it. That's how I want to kind of structure the rest of this talk. And so first of those was political problems, as you might imagine. So just the organizational politics, the interagency politics with regards to how we are dealing and interfacing with customers, with upstream and downstream providers, et cetera. There was, of course, technical challenges, which are in some ways more interesting and more challenging. And then there were procedural challenges. So the first thing on the political front. So a lot of the engineering, a lot of the IT, a lot of the folks who have been there for a while, or they grew up on this project, or this project grew up with them, and it was their special baby. There was a lot of questions that were very much centered on, we've always done it this way, it's always worked, why do we have to change it? And Billy Bob over there knows how this thing works. Why do we have to pester anybody else but him over there to do this particular thing? And why do we have to write it down? Because he's there to take care of it for us. And because these things have always worked in the way that these folks have operated, there's a lot of fear surrounding any potential change. And they knew that that change was partially attributable to the technical fragility of the systems, but it was also due to the fact that customers were happy for the most part. The customers that they had were pleased, they kept paying us, and so why are we going to fix what is not broken? It's like consistently using a credit card and just paying the minimum payment and saying, well, I'm not bankrupt yet, but you inevitably will be, or especially if you keep using that credit card and your minimum payment continues to pile up. And let's say you lose your job one day, all of a sudden your ability to pay down that debt instantly evaporates. We also ran into a lot of the questions of, these things are no longer a priority. So because we passed some initial audits, why do we still care about security? We've probably all heard this working in and around the security field. Why, once we get past those check marks, do we want to invest more money into this? We need to invest more money into features. We need to invest more money into more customers, business development, things like that. The things that are going to make the business money, not prevent money from going out the door, which is a dangerous way of talking, as you guys probably are all well aware. So a couple of solutions that we had here. This was more about how we framed the kind of work that we did. So instead of sitting there and poking holes and everything, we really tried to focus our efforts on enabling. And this was like ripped out of the whole Phoenix Project style. We've had folks who have read the Phoenix Project. Yep, we have some hands raised. For anyone who has not read it, highly recommend it. It is like the DevOps manifesto of sorts. Fantastic book. But basically, our entire mantra was all themed around enabling. And so to do that, we had to really focus in on a very small and targeted set of things. We couldn't focus on this big, grandiose set of capabilities. We've probably all seen the CISO mind maps and stuff where, in order to have this robust security program, you have to be doing 1,000,001 things. You have to have threat intelligence capabilities, and you have to have artificial intelligence sprinkled all over your security program, and you have to, basically have like the Terminators running around protecting your organization. And it's not really realistic. A lot of the vendor speak that you'll get is that you have to be sprinting like a full-on Olympian before you can even crawl, which is not really effective because you're then just taking on more kind of debt for your own team, and they're looking at more things and trying to do stuff that they can't really do and act on. They're ingesting information that they can't act on, and it's more money flying out the window for you, and it's more debt and load placed on their shoulders. The other big thing for us here, and that enablement mindset was us interfacing with engineers, for what it's worth. With regards to upper management, this was also really, really important. And I think the most important thing here was, instead of operating in the mindset of ordinal risk scales, where we're going to go in and tell the board, the exec team, the engineering teams, et cetera, that we've got 30 high-risk findings and 50 medium-risk findings and 100 low-risk findings. If somebody wants to shout out and give me a definition of what does high risk mean? Anybody?
Big impact on the business.
All right, so we had big impact on the business. Anybody else?
More than 50K in damage.
Okay, so yeah, pick a number more than 50K in damage, potentially. It could also potentially mean that something is really likely to happen, but maybe has a little bit less of an impact. I don't know. It depends on, a lot of it just depends on that organization's threshold of risk. But ultimately, what we tried to do here, and this was based on a study that the CIA did a while ago. It was called The Psychology of Intelligence Analysis. And in that study, what they ended up doing was they took ordinal risk scales like high, medium, low, and they went through and they experimented with, they did like A/B testing with those high, medium, and low risk scales. and they presented them to different people who were experts in the field of the things that they were presenting on, and they presented them in different orders, at different times of the day. They had different people present them. And what they found was that based on all of the ways that they could present and order these risks, even though they are the exact same risks, the exact same numbers, that people's interpretations of them varied really, really significantly. And so if I go and tell somebody that, I found hard-coded secrets in your source code, like in your source code, and this is a big problem, and it's a high-risk issue, if I tell that to 10 different engineers, they're going to interpret it in 10 different ways. And that's a really, really big issue if you're trying to get things done. And if I go tell that to an executive who is non-technical, that's an even bigger issue because they're, it's like, how do I weigh that against, my BD people who are telling me if I can deliver these 10 new features that are going to dedicate the same amount of engineering time potentially. How do I weigh which one is more important? That one's going to make me X millions of dollars. This one's, I don't know what this is going to do. You're just telling me it's high risk. And so what we ended up doing is instead of saying anything is high, medium, or low risk, we gathered a few different information points about each vulnerability. And this led to a lot of just arguing and bickering among our security team, which arguably you should be doing whenever a vulnerability comes in. You shouldn't trust things at face value that a tool spits out at you, et cetera. But we would say, what is the actual likelihood? Throw a percentage on it that this thing is going to happen in the next 6 months, 12 months, whatever. Let's say if it's a publicly accessible server and it's unpatched, it's 80% chance that it's going to get tipped over. Bump that up to like damn near 100% if there's a public exploit for it or something to that effect. And then based on what that thing is, we would put in place a range, a lower bound and an upper bound of what that is going to cost us impact-wise, dollar-wise. And that could be in terms of productivity. It could be money flying out the door due to fines. It could be customer confidence or revenues lost, things to that effect. But then this allowed us to have a much more informed conversation with upper management and product teams who are influencing the scheduling of certain maintenance tasks, specifically security tasks in our case, to say you've got an 85% chance that this risk event is going to get actualized. And when it gets actualized, or if/when it gets actualized, it will cost you anywhere from this to this, or it will cost the organization anywhere from this to this. Only X percentage of which is coverable by cyber liability insurance. I don't know if anyone has ever successfully seen a cyber liability insurance claim get paid out. I saw like 1/10 of one get paid out, and that was it. You pay like tens and tens of thousands of dollars for these things every year. It's like worse than auto insurance. It's terrible. So that really helped us with the folks who are driving the scheduling. And then we also went to a lot of these other stakeholders, not just engineering and product teams, and we started to get them on our team. And so in talking with sales and marketing and the folks who are actually doing business development, if we could tell a story around why a security issue or why this accumulating debt was going to potentially impact the work that they were trying to do, then they're much more compelled to say, all right, well, we know that we're trying to push features that are nice to haves, not necessarily must haves. But if our customers care about the security of their healthcare data, and we know that they do, and that becomes a must have versus a nice to have, then they can also make requests on our behalf into the product and engineering organization to help push our agenda. And so we did this a lot with completely non-technical stakeholders, and we went after them and we told them our stories. We would help them make their case. We'd promise to help them on things. We would grease wheels a little bit that way, and one hand helps the other kind of thing. And we found that to be very, very successful. So the next bucket of challenges that we went through were, of course, the technical issues. And in this case, as I mentioned, we had a lot of hand-rolled things. And to everyone's credit, we did actually attempt to codify some bit of infrastructure. We were using Ansible for some deployments. And we had a little Slack bot that would do deploys. So you'd do like /deploy bot and tell it what you wanted to deploy, and it was all good. Some Ansible scripts would run. It would provision a system, and it would boot up, load the code on, and it was all good to go. But what we ended up happening is, because there was a lot of missing tests and missing production-ready monitoring, things would inevitably go wrong if they were up for too long. For example, if we were not deploying on like a monthly basis, a weekly basis, a daily basis, they would just kind of sit there. Things would atrophy, things would go wrong. You'd have memory leaks, you'd have any number of issues, and then somebody would SSH into the thing. When they SSH into the box, they would inevitably start changing things. They would leave it running, and you can probably guess, as that thing is running, if we've got 100 production hosts, each of which has been SSH'd into at any number or any point in time, and had unique changes made to that particular production host, you basically have 100 different, it is effectively different in unknown ways, running instances out there that you then have to maintain. But you really your mental model tells you have one instance out there, because you're expecting them to all be deployed and extrapolated from the same golden image, the same packaged up code, running the same versions. Maybe there's dev test instances, what have you, but they should be roughly equivalent. And this was not the case. And because there was very little monitoring, there was very little ability for us to make any kind of assertions. So for instance, how many instances in our fleet were running this particular type of software, this particular operating system version? Consider when vulnerabilities like Heartbleed got released, how quick everyone was trying to scramble to figure out if they were running the particular vulnerable libraries that Heartbleed affected. And there are some people who could recover very, very quickly as soon as a patch got released, or if they got early access to said patch, they could really quickly check, deploy, and they knew exactly what their exposure was. For those that didn't, it was a much, much different story. And so we ended up relying on a lot of tools in this case. And if anyone if folks are familiar with these set of tools, what a lot of these, and these are not like exhaustive or any means, this is just a sampling of the things that we ended up using. But what you'll notice, the theme here is that all of these are codified in some form or fashion. They can all be instrumented or controlled through some form of configuration, some form of scriptable thing that we can put in source control. Except for Splunk, but I mean, we would just deploy a Splunk agent, and then that would get us logs. But everything else was geared around the idea that we could have some kind of configuration or some kind of state that we put in source control. It was versioned, and that state that was in source control is what existed on the box, or what, in the case of CloudFormation, what represented the ongoing active AWS infrastructure, for example. And so, as you might imagine from that list of tools, one of our big focuses here was trying to make as much of our infrastructure codified as we possibly could. And what we found when we first started having this conversation is that a lot of people were very much focused on like one aspect of the infrastructure as code process. They had seen like a presentation from Chef or Puppet or something like that, or they already had familiarity with Ansible, and so they were familiar with that one slice of the overall stack that was codified, and that was kind of enough for them. But if you really start to break it down, there's this whole pipeline of things that need to be codified. There's the initial git commit that somebody's going to make. You want security checks running on that code when it enters your repos, or potentially before, like a pre-commit hook or pre-receive hook. You don't want people making manual changes to your AWS or Google Cloud infrastructure, or Heroku, or whatever you happen to be running on, or your own manually provisioned infrastructure. You want all of that infrastructure, and you want that entire workflow from git commit to packaged up deploy on a server to be codified in some some structured fashion. And so you can point to exactly what represents your pipeline. And so the first step here was really enumerating the entire set of things that represented our deployment pipeline, or our development and deployment pipeline. And then we had to start small, because you can't just, Rome was not built in a night or in a day. And so we had to start very, very small. We focused on the things that were the most expensive, or that were where there was the most sprawl. And so for us, that happened to be AWS infrastructure. So at the time, all engineers had AWS access. It wasn't all root super admin access, but they all had AWS access in some form or fashion. They were in the console, clicking buttons. I don't know if anyone has familiarity with the AWS console, but it's not the prettiest console in the world. There's a lot of buttons that are hidden in a lot of different places. And so it's very easy to experiment around in the AWS console and try to find what in the world you're looking for, and click a lot of buttons along the way. And there's not really a good rollback mechanism, or if any rollback mechanism that exists, other than snapshotting something, which you must intentionally do, and then roll it back, which you also must have a capability to do. So it's not as easy as just the Command Z undo, like if you are typing a document or something like that. So we had to start building guardrails around AWS infrastructure, and that's where CloudFormation came in. For anyone who has used CloudFormation as well, I would advise folks to not use the raw CloudFormation tooling itself. It's a little bit like a bull in a china shop with a hammer attached to it. It is not very nice about telling you where you're going to potentially destroy something. It has no knowledge of the state in which it's about to burst onto, like that Batman scene that I had flashed up here earlier. That is basically CloudFormation coming into your AWS environment and just like Kool-Aid Manning in and just wrecking whatever is in its path and doing whatever. I mean, you're telling it to do stuff, but you don't know what it's actually going to do in reality. And so I would recommend one of those abstraction layers around it that has some sense of state, for what it's worth. And we can talk tooling and stuff after this if you guys want. But start with the guardrails. And so we set up templates for people to create S3 buckets that had encrypted, that enforced the SSE flag as policy. You couldn't do any S3 buckets unless you had them set up in this way. You ran this CloudFormation template, wham bam, and you're done. And you have a compliant, secure S3 bucket. Then we started creating some process and some controls around how people created security groups. And so we didn't have all of these security groups that were just blatantly wide open to the world and attached to every instance. And then we started creating ones for EBS volumes, for RDS instances, for Redshift clusters, and we slowly but surely started to codify our AWS infrastructure. And then what we ended up having to do was then go back and build in monitoring or checks to find stuff that was not created by that automated infrastructure, and the stuff that persisted in that manual snowflake fashion. And for that, what we ended up finding was that tags applied by some kind of CI server or some kind of automated process was super, super helpful. We could tag things with a release. We could tag things with a certain with the tool that created it, with the person that created it, with the timestamp it was created, things like that. If an instance got SSH'd into, we could have a Lambda function that went in and marked it as dirty or something like that, and then mark it for redeploy after the fact. There's a whole bunch of things that we could do to slowly start to remove or reduce that snowflake infrastructure. And then at the end of it, we end up with much more stable infrastructure that we actually, we can provide CloudFormation templates to an auditor even, which we've had success doing, and say, here is, instead of giving you access to the console, which, you're not going to be able to find your way around anyways, because it's an AWS console, here is some templates, and you can go through and see exactly what ports are open. You can see exactly what settings. It's all commented for you, et cetera, et cetera. And it's much easier to understand and make assertions about. And the same thing went for applications. So we used we're a heavy Python shop. We just started experimenting in Go. So we started off with Bandit. If anyone's familiar with the tool, we built a bunch of custom checks Then we started off using Gas, which is another Python-like linting tool, integrated those into the Git flow process, things like that. And one big thing that I want to emphasize here is that we tried to use some of the concepts from test-driven development to improve our process. And so we would start by writing a test for a thing, whether it's some crappy AWS state like S3 buckets, not using the SSE flag or not being CloudFormed or et cetera, et cetera. We would describe a compliant or ideal state in the form of a test. We would run it, and we would keep running it, and we would keep posting the results into Slack until we were able to make the changes, and those tests came back green after a certain point. And so eventually, what that ended up giving us is that we, of course, during the improvement process, we could see how we were doing, and we could make assertions about things. But one of the other really nice benefits that came from that is that over time, if anyone does make a snowflake change in the future, we've got tests automatically running that will catch those things faster, and so we can respond to them sooner. Or we can just set something up to automatically kill it and have it be event-driven based off of the result of our test. And so we found taking that test-driven approach was really, really effective for us. Highly recommend. And so the last bucket of things was on the process. People, tech, and process. So how many folks have ever worked in an environment where you have somebody experimenting with things, they're tinkering, and then that experiment all of a sudden becomes mission-critical business software? Yes. So when you're experimenting with something, those things are oftentimes not done with production rigor, because that would slow the experiment down exponentially. You don't want to have to go through and apply the entire set of like ISO 27000 controls to a little bit of experimental code, because what's the point of experimenting if you have to spend several months doing it? They want engineers want really quick, fast experiments. But if they run an experiment and after doing so, people love it and they automatically escalate it up to production status, you're going to be in trouble, because then you have more of this snowflake one-off code kind of running everywhere. And then as part of that, if people are not doing pairing, if they're not writing things down, things like that, you have a lot of this knowledge silo followed by attrition or bust factor incidents, as we had. I've heard horror stories in some organizations in the Valley where you would have somebody had set up a system, they leave the company, their key was the only one on that box, they don't know how to redeploy it, and you've got people literally like tweeting at the person, seeing if they happen to like steal, take their keys with them, if you will, and you're almost like welcoming the fact that, or hoping for the fact that they did steal company property or take things with them after they left, so that way you can maintain your system. And it's, instead of being a big issue, it's a sigh of relief. And unfortunately, these stories are real, they happen. And then of course, we talked about this stuff a little bit earlier, but if things can't be maintained, then they're left running forever. If they're left running forever, then they inevitably atrophy. And then of course, if they, at some point they become too critical in the organization, then and they're atrophied too far, then they become too fragile to make any changes. And if they're too expensive, then the risk you're trying to mitigate by making changes to it, then the business is going to win and just shut you down. And so, and what we ended up finding is that we had this whole set of just organizational debt through process. And so we ended up creating new things to solve these problems. And so we just had more stuff kind of compounding on itself. It was like it was like paying your bills with your credit card. And so similar to the technology debt consolidation, we ended up doing a very similar thing for the process consolidation. And so here, we started off, we identified all of the mission-critical processes that were helping us serve the strategic objectives for the organization. In our case, it was keep our customers happy, keep systems up, and keep systems secure. Those were like the three things that we focused on. And so we had processes like, how do we redeploy the VPN? How do we check code in? How do we maintain the How do we maintain the Git server? How do we maintain Jenkins? How do we maintain, like who maintains the CloudFormation abstraction tooling that we're using, things like that. And this took a lot of doing, but we did like hack days just to figure out something, like reverse engineer something, because people left, people forgot, et cetera. And we would just go through and reverse engineer everything and then document the hell out of it. Once you document everything, even if it's a 30-step list, you have a run book with which to work. You have a starting point. And then for us, we just really focused on writing code in very small batches to say, if you can take a run book and turn it from 30 steps to 25 steps with a script, great. The next iteration, you next stab, you get at it. You can take it from 25 steps down to 15, and eventually you can get that process or that run book down to a single button. And one of the big cultural things that we really had to push on people with documentation was that most people write docs, they write them once, they never touch the docs again. They're like, well, documentation was written. It's like, we've all seen it when we go to use an open source project. It's like, damn it, if this thing didn't run on the dev system, it doesn't run on mine. The README hasn't been updated since the project first started. Screw it, I'm gonna go write my own. And so, whenever we found bugs in the doc, very much like bugs in code, we had to make it a culture thing to go back and fix the bugs in the doc. We tracked and handled those very much like we would technical bugs. And so, one of the things to consider here is my particular situation here was very much focused on a small set of focused products. When you're thinking about this stuff at scale, if you're working in a large enterprise or alongside a large enterprise, is they're going to have tons of legacy IT systems that have just kind of accumulated over the years, or things that are serving some business process. And there's a lot of bloat that just gets distributed everywhere. And so executives are then forced to make the decision between paying down that organizational and technical debt across an entire portfolio of things versus bringing in new projects that are going to make the enterprise money. And so one thing that I wanted to call out here is that I've seen this work very nicely in large organizations in my consulting days, is that taking a portfolio management approach where you map out everything, like all the applications you're maintaining or all the servers that are up or something, like all of the basic inventory stuff that we're gonna wanna see anyways. If you have that and you can attach some kind of number, even if it's not entirely accurate, that represents the total cost of ownership or the total cost of downtime for that thing, and you can map it to some kind of business process or like some kind of what in the hell does this thing do question and answer, then you can start to just work your way from the bottom up. If you have like this outdated thing that serves a process that only one person in the company cares about, yet it represents a fairly significant chunk on your budget list or your application inventory list, and it's expensive to maintain. Nobody wants to touch it. It gets included in audit scopes, things like that. See if you can just remove it. See if you can just kill it. And if you slowly start to just work your way, like small targeted projects, not doing this stuff at a big grandiose scale, you'll slowly but surely chip away at it. So wrapping things up, I've got wrap up and then some like actionable things that I always like to leave, like a couple of to-dos for everyone, homework, if you will. So this problem almost always starts with misaligned priorities, which in my opinion isn't always a bad thing. Engineering teams are going to be focused on building features. Business people are focused on stirring up, building the brand, bringing money into the organization, things like that. And those are not always a terrible thing, but over time you have to start to bring people back together and figure out where the mutually aligned benefits exist. And then don't believe the vendor snake oil here. This is going to be a really big one. Almost all folks will tell you that they've got the silver bullet to solve your problem, and it is absolutely not true. You could even look at like the Gartner like maps, And the fact that there are so many different segments out there tell you that each one plays in a different space. And so, as nice as steak dinners are, don't fall victim to the snake oil. And I don't say this to say that vendors are necessarily bad. They can help you get a lot of things done, but don't believe for a second that they're going to solve all your problems. You have to figure out where to apply them in an intelligent, useful fashion. You have to think about your program systematically, and you have to use them as tools in a much larger picture. And then one thing that I think is really important here is don't design just for security up front. Don't just focus on like building security into your system and focusing on the SDL and everything's going to be all right, because if a system starts secure but you can't make changes to it, it will over time not be secure. And I think that's a really important thing that is oftentimes neglected in our industry jargon and talking. And so 3 things that I think are worthwhile taking away from this. First thing is, within your organizations, find the systems or processes that exist around your organization, who in the world owns them, what the cost of those things are. Even if you just ballpark it, even if you just put a label on it, like a lot, not a lot, that's still going to help you just start to visualize where the most amount of debt lies around your organization. And then try to find that 80-20 type of improvement area. So sometimes, you don't want to take on the big 80% amount of your effort to have a very small marginal improvement. You want to make small marginal improvements, or you want to make small investments in your time and resources to have big returns on investment. Sometimes it doesn't always work, but my bet is that if you really start to map these things out and figure out where all of your time is going, and this might even go for like unplanned, like interrupt work on your own team. For instance, on our security team, we found that we were handling a lot of access control requests, and they were constantly just burdening us, and we're doing a lot of interfacing, and our purple team was like constantly bogged down with like nagging people anytime security alerts came in. And so we just made some investments in like little Slack bots to handle, like we can type /request access, and we handle we have a Slack bot just manage all of the manager middleman communication. It just logs something for us. We can veto things if we want. We can, we write little tests in there about the things that we want to improve, but we automate away the things that are taking up the most of our time. And then with regards to critical processes, this is all about not letting yourself fall victim to the bus factor. And so I think that process is oftentimes tightly coupled with technology solutions, or like a piece of technology that might need to be maintained at some point. But always make sure that you define documentation for a process for a piece of technology as part of the condition that is done. So don't call a project done if it's not documented, if multiple people haven't run through it, if it's not tested, things like that. Like if you bake those things into the circumstances that are going to let that thing proceed from experiment to production-ready system and production-ready infrastructure, and you consistently every couple of months or so run through the run book, see if it's still accurate, and if it's not, fix it. Treat it like bugs, and I think you'll find yourself in a good place. And so with that, thank you. And does anyone have any questions?